Hi everyone, what we're going to look at today is some characteristics of a parabola. So we're going to kind of break down each of these definitions and see what it looks like on our graph. So when we have a parabola, we have this U shape. It's either kind of this downwards facing U or this upwards facing U shape. So that's what the graph looks like when we're talking about a parabola, where we're in that form y equals ax squared plus bx plus c. So we have that x squared as our highest exponent. So going through our definitions, the first one is a vertex point. Well, the vertex point is just your highest or your lowest point. Think your minimum or your maximum. In this example right here, we have a maximum point for that vertex at the point 5, 8. The next thing we look at is the axis of symmetry. The axis of symmetry is a line that kind of splits our graph right in half. So the definition is that it splits our graph right in half. It's always a line x equals some value. And what it always is going to be, it's going to be that x coordinate of that vertex. So in this situation, this line, this dotted line, cuts our graph right in half, that if I were to fold them on top of each other, they would kind of match perfectly. So in this example, it's always x equals 5. So you have to make sure you make it a line x equals. You can't just put 5. It's the line x equals 5. The next thing we're going to look at is the y-intercept. We've talked about this the entire year. The y-intercept is where it crosses the y-axis. So the x-coordinate is 0. Here, we can see that it's 0, c, or whatever that last value in when we have the equation given. So it's always that c value. It's when the x-coordinate is 0. Here, we can see that it's the point 0, -5. The next thing we have is this reflection point, and this is going to help us a lot when we're graphing, especially that we can kind of create that U shape. Notice that it's that reflection point reflects as many as possible so we can get that graph, but it's going to be equal distant from that axis of symmetry. So 0, 5, -5, then the point 10, -5 would help us out so that we can see that we have this reflection. So when I fold it over that axis of symmetry, we once again have that perfect match. So a reflection point, think that we need to reflect as many as possible to help us create that graph. Just one example is that point 10, -5 to help us out. The next one we look at is the x-intercepts, and we were solving for x-intercepts in the last chapter when we were solving by factoring. The x-intercept is where it crosses that x-axis. So here we have two x-intercepts. So the x-intercept we factor and solve when we're given an equation to help us out. In this example, we have two x-intercepts. We have an x-intercept at 1, 0 and at 9, 0. So remember, the x-intercept is where it crosses that x-axis, so the y-coordinate is always 0. When we solve by factoring, just like we did last chapter, we set the equation equal to 0. We factor, then we use that 0 product property and set each factor equal to 0 and solve from there. Now, the next two are new definitions. They're increasing interval and decreasing interval. So when we talk about an interval, it's that starting and stopping point. So an increasing interval is when the graph goes up. I like to think about it that if you're going up on a roller coaster, it's increasing. So an increasing interval is when the graph goes up. See here, the graph is going up. So we're going to write it as an inequality because it's not just one set and stopping point when we have these arrows going on. So in this example, x is less than 5 is all the places where the x-coordinate is less than 5, the graph is increasing. We're getting closer and closer to that top of that roller coaster. The next one is a decreasing interval. Once again, an interval. It's where the graph is going downward. You're going down on that roller coaster. So here we're decreasing for all the values of x that are greater than 5. So when x is 10, we're going down, whereas when x is 0, we're going up. So we always write these intervals. It's not necessarily that ordered pair. It's that interval is an inequality into telling us when our graph is going up and when our graph is going down. The last two definitions are things that we've seen way earlier in the year, domain and range. Remember, domain is all of our x values, and range is all of our y values. Here in our parabola, that domain, that x values, we look left to right. There's nothing restricting my graph. So here, the domain goes on forever left to right. So we would say all real numbers. But when I look at my range, we want to go bottom to top. And notice that I have this kind of stopping point here, right at that vertex 5, 8. There's nothing greater y value-wise than 8. So when we talk about the range is going to be, we use that y value of the vertex. In this case, because we have this maximum at 5, 8, we have a maximum at 5, 8. The y values are all these values like -5 and 0 and +2. There's nothing greater than that +8. So we would say that y is less than or equal to 8. What we're going to do on the next one is just some examples using this information. So here we have another graph. This is given y equals x squared plus 2x minus 3. The first thing that I did was fill in some important things. I filled in the dots that I knew were going to help me out. So the first thing we have is the vertex. The vertex is that high or low point. So right here, we have our vertex. That vertex is at the point -1, -4. Now this green dotted line that I drew in, that's our axis of symmetry. It's always going to be the line x equals, and then you just take the x coordinate of your vertex. So it's going to be the line, always a line, x equals -1. The y-intercept. Now the y-intercept, we said, is always going to be that c value in our equation. The c value is that constant, so c, it's at -3. We can also see right here, it's the point 0, -3. So our y-intercept should be 0, -3. In the previous page, it's where the x-coordinate is 0, where it's crossing that y-intercept. Now the x-intercepts, we can look at the graph and figure them out, or we can factor and solve. So let me show you that. So we take the equation and we set it equal to 0. This is from last chapter. What two numbers multiply to -3 but add to +2? The only combination that works is x plus 3 times the quantity x minus 1. Since I'm solving with that equal sign, I set each factor equal to 0, and I solve. So I'm getting the two answers of -3 and +1, which we can write as ordered pairs. The two ordered pairs that we see are -3, 0 and 1, 0, which is what we have as our two x-intercepts. Domain, there's nothing stopping my graph left or right. There's always going to be values when x is -7, -10, even if we can't see it. The graph is going on forever. So the domain is all real numbers. But here for the range, when I go bottom to top, nothing's happening down here when I get to -10 or -8 or -5. This minimum point of my vertex, -1, -4. So my range is y is greater than or equal to -4. Think that I have this line right here, and nothing is below it. Everything is above. So all my y values have to be greater than or equal to -4. That -4 is always going to come into play as your y coordinate of your vertex. When we talk about increasing or decreasing, these are intervals. So we have a kind of that set stop and starting point of where our graph is decreasing. We have these arrows, so we're going to say that we're increasing for x values that are greater than -1. Notice here when we go back to increasing and decreasing, we use the x coordinate. Increasing and decreasing, we always use the x coordinate. The x coordinate was at vertex, -1. It's all coming back to this -1 spot. -1, -1. And we're decreasing, we're going down on the roller coaster when we have x values like -3 and -2 and -10. So as an inequality, we would say x values that are less than -1. So use this vertex point to help see that we're decreasing, going down on the roller coaster, and then we're increasing, we're going up on the roller coaster. We write this as an interval, so we use our inequality notation to help us out. Here we have that parabola, that upwards U shape, making our vertex that minimum. In this next example, We once again have this parabola shape, but here we see that we're going to have that downwards facing parabola. So our vertex is going to be that maximum point. So let's go through these values. So the first one is a vertex. That vertex is that ordered pair. That's your high or your low point. So we can see right off the bat that that vertex is going to be at 7, positive 1. That dotted line that's green, that's your axis of symmetry that cuts your graph right in half. It's always going to be the line x equals, and then you take the x coordinate of your vertex. So it's always going to be x equals, and then you take the x coordinate of your vertex. The y-intercept, here it's a little tricky. We can't see it on the graph. We don't see a spot where we're crossing that y-axis, but we can use the c value of my equation to help me out. So we should see the y-intercept, if we were to keep graphing and zooming out, would be at 0, negative 48. Here we can see our two x-intercepts are going to be at 6, 0, and 8, 0. So here we can just pull them right off the graph. Our two x-intercepts. X-intercept is where it crosses the x-axis, so the y-coordinate is always 0. So here we have 6, 0 and 8, 0, two separate ordered pairs because we're crossing twice. Domain for our parabola is going to be all real numbers. We have nothing stopping my graph. Range. Think here that I have this maximum value. So nothing is getting above that y-coordinate of positive 1. So my range is all y values that are less than or equal to 1. I don't see a y value that's going to be 13, but I see a y value that's going to be negative 5 or negative 10. So all the y values that are less than or equal to positive 1. If you get stuck where that positive 1 came from, it's coming right back from this y-coordinate of your vertex. Increasing and decreasing are intervals. And we use this when we talk about x. So we're going back to that positive 7 to help us out, because that's what's looking at how we're increasing and how we're decreasing. We're increasing over the interval when x is less than 7. So if you get stuck, think of a number. Well, I know I'm increasing when x is 4. So I have to say x is less than 7. And I know that I'm decreasing on this interval when I have numbers like 8 and 10. So it's when x is greater than 7. We don't put the inequality like equal to underneath here, because here at 7 exactly, it's not increasing or decreasing, it's that change. So once again, that interval is always going to be using that x coordinate of your vertex. And your range is using that y coordinate. So hopefully we have a good understanding of our main key terms of vertex, axis of symmetry, y-intercept, x-intercept, domain, range, increasing and decreasing intervals.